Okay, stats. This is the beginning of Chapter 5. We'll do 5.1. Again, your test will open Wednesday at noon, and will be open until Saturday at 3. Which you need to start it by probably 1. I'll send out another email about the length and for people's accommodations, how much time they'll get as well. Chapter 5 is all about probability. Probability is the measure of the likelihood of an event. It's basically, we usually use decimal form, but like the percent chance of something happening. The law of large numbers states as you repeat an experiment over and over, you should be getting closer to the actual probability of the outcome. So of course, if you flip one coin, you have a 50% chance of getting heads and tails, assuming it's fair. Now if you flip only one coin, you're never going to get 50% heads or 50% tails. But what they're saying is if you flip a coin 100, 1,000, 10,000 times, you should get pretty close after a while, so 50% on both sides. You may not be exactly there, but you should be like within 49 to 51, something like that. Considering the probability experiment of having 2 children. So it's a probability experiment if you're doing something repeatedly and they're independent trials. So you could have 2 boys, a boy and then a girl and then a boy, or 2 girls. These are all the possible outcomes when you have 2 children. The sample space is just all of these things listed out. Boy, 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 girl, girl, boy, girl, girl. Define the event E as having 1 boy. That means E is the group boy, girl, or girl, boy, which means it should be a 2 out of 4 chance that you would have 1 boy, or 1/2. So there are some rules for probabilities. Your probability should never be less than 0. It should never be bigger than 1. Because the probability of 0 means it can't happen. The probability of 1 means it's guaranteed to happen. And the sum of all probabilities must be equal to 1. You can't say I'm going to flip a coin and I have an 80% chance to flip a heads and an 80% chance to flip a tails. Those percents or decimals have to add to 1. Okay, so sometimes you'll need to be able to look at tables and know whether or not they're a probability model. Probability model lists all the possible outcomes of an experiment and the probability. So we still need to use our rules so that everything adds to 1 and all of the data pieces are between 0 and 1. So in a bag of peanut M&M milk chocolate candies, the colors of the candies can be brown, yellow, red, blue, orange, or green. Suppose that a candy is randomly selected. The table shows each color and the probability of drawing that color. Verify this is a probability model. All they're saying is, are all the numbers between 0 and 1? Yes. When I add them all together, that's 0.27, 0.39, 0.62, 0.85, 1. So it hits both of those, then it's a probability model. Now what about these ones below? Are they probability models or not? The moment you see a negative, you say not a probability model. Because of negative 0.12 is less than 0. Can't be less than 0. Over here on the right, if you add all these up, it's 0.47, 0.6, 0.8, 1.03, 1.14. Is that right? I think it's right. So that means all of these together add to 1.14, which means not a probability model, as the total isn't 1. So those are the 2 reasons it could not be a probability model. If it doesn't add all to 1, or if you have any negative numbers, that's not a probability model. Empirical approach. The probability of an event is approximately the number of times the event is observed divided by the number of repetitions of the experiment. This is when you're doing a experiment, if you've done an experiment and you want to find the probabilities, you're just going to use the data from your experiment. So Pass the Pigs is a Milton Bradley game in which pigs are used as dice. Points are earned based on the way the pig lands. There are 6 possible outcomes when one pig is tossed. A class of 52 students rolled the pigs 3,939 times. The number of times each outcome occurred is recorded in the table on the right. So it could land on either one of its sides facing up, the side with a dot or the side with a no dot. Razorback, I think maybe is on its back. Trotter, I think, is on its feet. Snouter is on its nose. And I think the leaning jowler is where it's like sitting on its butt. So it's kind of an interesting game. So compute the probabilities. All they're asking you to do is to take those numbers and divide them by 3,939. So a side with no dot had 1,344. So we take 1,344 and divide by 3,939. We'll go 3 decimal places, so 0.341, because I'm going to write the fractions here. Side with a dot is 1294 over 3939. We'll get a decimal for this one as well. 0.329 if we're rounding. Razorback 767 over 3939. .194. Trotter 365 over 3939. Which is 0.093. Snouter is 137 over 3939, which is 0.034. And lastly, the leaning jowler is 32 over 3939, which is 0.008. Now with rounding, sometimes your numbers may not add up to the exact total of 1, but if you do this right, the fractions should add up to 1 without rounding. And this is our first experiment. We will do more and finish 5.1 in the next video.